We are the Galactic Enforcers. Our base of operations is located on the planet Venus in our solar system. We provide transportation of prisoners to a first-rate facility on a comet in the Andromeda Galaxy. It is our personal guarantee that any prisoners transported using our ships will reach our prison without any incidents. The universe contains about 100 billion or more galaxies, which are large collections of gas, dust, and billions of stars. Galaxies move together through the universe and can even collide. Galaxies are classified by their shape. Spiral galaxies are shaped like pinwheels with spiral arms. Our galaxy, the Milky Way, is a spiral galaxy. Elliptical galaxies look like spheres or ovals without spiral arms. Irregular galaxies appear blobby without any real shape. These are areas of active star formation. Stars within galaxies are bright and hot bodies composed primarily of hydrogen and helium gases. Stars are classified by their size, temperature, and brightness. A spectroscope is a tool used by astronomers to determine the composition of a star. It can tell us the composition by spreading out the light into its different wavelengths, which are distinct for each element composing a star. There are billions of stars in Andromeda, but we've chosen to place our prison on a comet that encircles a particular star named Alpha Andromeda, or Alpha-Rats, the brightest star in that galaxy. Alpha Andromeda is actually a binary system of two stars in very close orbit that appear to be one. It is very hot, about twice as hot as our Sun, or about 13,000 kelvins, and bright with an apparent magnitude of 2.7. For comparison, our Sun is of average size, temperature, and brightness. The prison will be built to withstand Alpha Andromeda's heat and brightness, but it won't exactly be a cool place for our prisoners to hang out. We would like you to choose our company because we know there are other companies that want this contract. Therefore, we have designed a sample transport to share with you. We have 5 prisoners in our sample transport. The ship has been designed with customized cells to prevent prisoner escape based on the powers of these prisoners. In addition, as a universal security measure, each prisoner will be put to sleep under general anesthesia for the entire journey, so they are disabled within their specially prepared cells. Let me introduce our prisoners. Experiment 523. He has the ability to freeze whatever he breathes on. He generates ice at will, he can turn himself into ice, break into pieces, and reassemble himself. Experiment 523's cell will be lined with heat lamps to disable his ice powers. Experiment 626 is a prisoner with super strength and intelligence. He is a quick thinker and troublemaker. His vision, hearing, and sense of smell are incredible. He can spit acid and pierce anything with his claws and teeth. He can lift things 3,000 times his weight, but he has one critical weakness, water. He cannot swim because he is so molecularly dense. Therefore, his cell will be a tank of water with the breathing apparatus supplying him oxygen with his confined area. Experiment 344 has an unusual trait, an appendage on his head which allows him to make duplicates of himself. Even though each duplicate is less powerful than its source, this could prove dangerous in containing this experiment. Consequently, we plan to block neural impulses to this appendage with a high dose of the drug atropine. Experiment 276 is the haunting ability to enter the heads of persons dreaming and convert their dreams into nightmares. If a person wakes up while he is in their head, he will remain there to turn all future dreams into nightmares. To prevent this catastrophe in the transport crew, Experiment 276 will be contained in solitary confinement in a 2-inch thick solid steel box with no windows and a solid door. In addition, the transport crew will be taught behavioral techniques to take control of their dreams in their sleep so they can wake up if they see him in a dream. Experiment 221 can turn his body into electricity so he can travel through outlets, power lines, and machines. He can fight by using electrical surges that disable his opponents. To manage this experiment, we will confine him in a room lined with 3-inch thick rubber insulation and no electric consuming devices in this chamber, such as lighting. So let's show our journey to the prison on the comet of Alpha Andromeda. We launched from Earth and began our voyage passing through our solar system in the Milky Way galaxy. We see the 8 planets that make up our solar system as we depart. We see our Sun, the closest star to Earth. Our Sun is a medium-sized yellow star made up of mostly hydrogen and helium. It is about average brightness and heat, so it falls in the middle of an HR diagram. It is about 5,778 K in temperature and about negative 26.8 in apparent magnitude or brightness. Stars brighter and hotter than the Sun are white or blue. Stars cooler and dimmer than the Sun are red. These are the most common kinds of stars in the Milky Way galaxy. Our ship can withstand temperatures up to 6,000 kelvin, so we are careful to stay away from any stars hotter than our own Sun. Larger stars have more of a gravitational pull, so we are careful not to approach these stars too closely so that we don't get pulled in. Our ship travels extremely fast to be able to reach the Andromeda Galaxy in a timely manner. Our spaceship is designed to travel at speeds up to 10 times the speed of light. This is necessary to reach destinations that are light years away. As we journey out from our solar system, we encounter many stars. There are ordinary main sequence stars which can become white dwarfs when they lose their outer layers but still have a hot core. Oh, there is a binary system of 2 stars now. There are Sirius A and Sirius B, part of the constellation Canis Major, or the Greater Dog. Sirius A is a main sequence star and Sirius B is a white dwarf. White dwarfs are small, so they are faint and they fade as they gradually cool down. It's easy to identify a white dwarf and easy for our ship to pass by one since they are not too hot or too bright. Just to be on the safe side, our ship has a chemical polarizing windshield that automatically darkens. We don't have to worry about being blinded by stars. White dwarfs like Sirius B may become novae if they drag matter, mostly hydrogen, from a nearby neighboring star and build up a surface layer that undergoes nuclear fusion in a burst, causing extra brightness and explosion of gas. This happens in a repeating pattern. We will want to stay a good distance from novae because they are bursting with energy. If a white dwarf accumulates so much matter that it collapses and explodes completely, it becomes a supernova. A supernova is a massive and bright explosion that signifies the end of a star's life. As a supernova collapses under the force of gravity, it becomes a small, dense neutron star. Supergiant stars that are extremely massive can collapse under the force of gravity and create a black hole, an invisible space where nothing can escape, not even light, and matter is sucked in by the extreme gravitational pull. The hot matter pulled in creates X-rays. As we travel 7.8 light years away from Earth, we encounter Wolf 359, a red dwarf in the constellation Leo. The constellation Leo, the Lion, in the northern sky from Earth contains the bright stars Regulus and Denebola. Wolf 359 is normally very dim, but because it is a flare star, its brightness can fluctuate. Its temperature is 2,430 Kelvin, accounting for its red color. Like most other stars, Wolf 359 is composed of hydrogen and helium for nuclear fusion purposes with small traces of heavier elements. When our ship arrives at our destination, we will be in the constellation Andromeda, seen from Earth in the northern sky. This constellation contains the Andromeda Galaxy, of course, and 2 dwarf elliptical galaxies. Along our route, we will avoid passing through nebulae, which are large clouds of gas and dust in space. They may glow red or blue or appear dark. We will avoid passing through them as our visibility will be reduced, but they are beautiful to witness from our ship. So our journey finally brings us in Andromeda. We recognize our destination of Andromeda because it is a spiral galaxy just like our Milky Way and the closest spiral galaxy to ours. We chose a comet for our prison because landings on comets were first made successful in the year 2014 when the Earth's Rosetta space probe landed on one. Comets are bodies of ice, dust, or gas like dirty snowballs. They travel around a star in oval-shaped orbits. They have tails that point away from our sun or the star that they circle. They are most likely remnants of the formation of solar systems. We did not choose 2 other possible locations for our prison, asteroids or meteoroids. Asteroids are rock fragments that circle planets and belts but occasionally hurtle into space. They shine as they reflect sunlight. Meteoroids are small rocks and solid particles that travel through space and can enter Earth's atmosphere, causing a glow and turning the meteoroid into a meteor. Meteors that strike the ground are meteorites and can cause meteorite craters in the Earth. Because the movements of asteroids and meteoroids are unpredictable, we definitely would not put a prison on one. You can safely trust the Galactic Enforcers with your prisoner transportation needs.